Okay. Um, okay, part A, try this.
Um, it would be, if you're multiplying it by 3, then it's 6a add 9b.
Mm-hmm.
And then multiply expression 2 by 2, 6a add 4, add 8b.
8b. And then part C, eliminate one variable. Any idea how you would do that?
Yeah, you get rid of the 6a.
And how?
You'd do 6a take away 6a.
Yeah. And so if you, let's call these expressions 3 and 4. If you did 3 minus 4, what would you be left with?
3
Like,
take away 4
no, sorry.
is,
Like top one, take away bottom one. What would you be left
oh,
with?
1b.
That's right. Okay. Okay, so same thing for each of these. You have to eliminate one variable by multiplying both of them.
So you could do at times, you could do the first part times 2
Mm-hmm.
and the second part times 3.
That's it. So what is the first one times 2? Actually,
First
no. I think it'd be okay for that one. How about part B?
Times the first one times 6 and the second one times 4.
Y times 6?
Because then you can get 12 and you can do 3 times 4 which equals 12.
Okay. Is there a smaller number that would work?
8 would work. Oh, no. 6 would work, sorry.
Yeah, getting them both to be 6. Okay, if you made them both 6, what would you get?
You'd get,
Yeah, go on.
oh, so you first have to do 5 times 3, which is 15.
Mm-hmm.
Then you get 6, add 6y.
Mm-hmm.
Then it's 12. Oh no, yeah, 12x minus
Hold on. No. What are we multiplying the second one by?
2, sorry.
Yeah.
So 4x take away 6y.
You have to multiply everything by 2.
Oh, yeah, 8x.
That's it. And how can you eliminate one variable from that?
Get rid of the 6y.
And how?
6y take away 6y.
And so what x's would be left over?
It would be 7x left.
So if you were to call these, let's say this is the top one, this is the bottom one. 6y, you would have to do 6y. Let's go back for a second to part A. So I did this thing that you said here. How would you eliminate the x's?
You do 6x, take away 6x.
Okay, and so what would the y's be then?
Minus 1y.
But because you did minus 6x, it becomes 8y minus 9y.
Oh, and that's an add.
Yeah.
So it would be 17.
And so you have to do something like plus or minus the two expressions. So top plus bottom or top minus bottom. So what would you do for this one to eliminate the y's? For B.
Would you just, since it's opposite, like sort of symbols, wouldn't you just take it away?
So if we go, oh, I deleted it from last week. The rule that we had was if they have the same sign, you subtract.
Yeah,
So 6x and 6x.
opposite signs is add.
That's right. And so we would add these two, and so what you get is 6y plus minus 6y, which gets rid of the y's.
Yeah.
So what x would you be left over with?
So you're doing, what's the equation again for it?
You're just doing top plus bottom.
Oh, so you'd have 23x.
Well done. Okay, and what would you do for part C?
Just do time by 3. Yeah, times by 3 on the top, times by 4 on the bottom.
Okay, what would that get you?
12a add 6c.
Mm-hmm.
And then 12a add 20c.
Okay. What's next?
Yeah, so then since it's the same sign, you subtract.
Mm-hmm.
So you'd have to do 12a minus 12a. So basically, you'd be left with 14c.
That is 20 minus 6. This is 6 minus 20.
Minus 14c.
That's it. Minus 14c. Okay, any questions there?
No.
And if you're ever stuck on what to multiply by, you just multiply by the other one. So you can see here you were getting the a is the same. The bottom a has a coefficient of 3, so you multiply the top one by 3. Top one has 4, so you multiply the bottom by 4. And you did the same for each of these. And that will give you an easy one there. Okay, you'll be okay for oh no, let's try this one.
So, alright, so you got to first of all write out 2x at 3y equals 11.
Mm-hmm.
And then 3x at 4y equals 15.
Mm-hmm.
So wait, are both of those? Yeah. So you get 6x at 9y. And you get 6x at 8y.
Now these are equations, so you have the other thing on the other side as well.
Oh yeah. And then equals 11 and equals 15.
You have to multiply everything by 3.
Oh yeah. So 33 and 45.
What are you multiplying the bottom one by?
Oh yeah. Sorry. So it'll be 30.
Well done.
Now you can clearly see that 1y equals 3.
Yeah.
Now you got that y equals 3, you can do 9 times 3, which is 27. Then the difference between 27 and 33 is 6. So x has to be 1.
That's it. Okay, any questions there? Any questions with that one?
No.
Okay, let's try this exam question.
So you first have to write it out.
Mm-hmm.
So you start off by trying to get it. So you can get 6x on both of them.
Mm-hmm.
So you do the first one times 2 and the second one times 3.
Mm-hmm.
So then you've got 6x plus 8y equals 10. And you already know that either x or y has got to be a minus number.
Okay.
So then you do 6x minus 9y equals 27.
Mm-hmm.
So you can tell by that the difference between 17y is 17. So y must equal 1.
Hold on. So you've got 8y minus 9y?
Oh, so it's an add. Oh, so the difference. Oh, yeah. I forgot to do this far. So 17y equals minus 17.
Yeah.
So y equals minus 1.
That's it.
And that you've got that, you can do, so it's minus 8y, or just minus 8. To get to 10, you need to add 12, and 12 divided by 6 is 2, so x must equal 2.
Okay, and it might be easier to use the original equations because the numbers are smaller in those, but you got it fine there.
Yeah.
Y is minus 1, 3x, 6, x is 2. Yeah. Okay, I think you'll be fine for these. They're very, very similar. Even something like this that looks like it's going to be more difficult. What would you get the same for these? What would you multiply the top one by? What would you multiply the bottom one by?
3.
Okay, and so the only difficult thing about this is this 2/3. Any idea what 2/3 times 3 is?
Sorry, what was the question?
What is 2/3 times 3?
6/8.
6/8 is the same as 2/3.
Yeah.
The way you do it is, well, there's two ways to do it. So if you turn it into a fraction, 3 divided by 1 is 3. So you can just do 2/3 times 3/1.
Yeah.
What do you get if you do that?
What times 3? So 2/3 times 3/1 is 6/3.
And simplify.
6/3. 2/1.
Yeah. And 2 divided by 1?
2 divided by 1 is 2.
Yeah. And so it seems like it's going to be a difficult question. Turns out it doesn't even give you a fraction there, so it's a simple question. And these simultaneous equations questions are all calculator. And so if you were stuck, you could do 2/3 times by 3, and your calculator would just give you 2 anyway. So you'll be fine there. Let's just construct the equation. How would you write this as simultaneous equations?
So you've got 2a add 3c equals 28.20.
Mm-hmm.
And there's 3a add 5c equals 45.75.
Yeah, and it's just the same from there.
Yeah.
It's the exact same idea. It's going to be the top one times 3, bottom one times 2. Your calculator is doing the work with the decimals, so there's really nothing extra difficult about it. Okay, let's try this one.
Oh, I hate this thing with those shapes. I actually need to learn how to do this. I have no idea how to even start.
Well, it says the perimeter of the triangle is 118. What is the perimeter of the triangle in terms of A and B?
So the triangle is 5a at 3b.
It's 5A at 3B. And what is 5A plus 3B equal to? Could you construct an equation from that?
I'm not sure how to.
Well, 5A and 3B is the perimeter.
Yes, that's the perimeter. So 5a times 3b, would that be the area?
Well, 5A plus 3B is the perimeter. The perimeter is 118.
Oh, so equals 118.
Yeah, and that's how you do these. Okay, how about so this rectangle, what would be the length of the top part?
A plus 3b.
Okay, and what would be the perimeter for this? How would you get that?
It would be 8a.
Yep.
Minus 2b.
Yep.
Yeah, that would be equals 114 centimeters.
114. Okay, let's do this one. So how do we find out what A and B are?
So there's a difference. So you need to do the multiplication thing again, won't you?
Yeah. Actually, you're fine for this question. It's really just the same. Well, like, what would you multiply the top one by?
2
Yeah, and the bottom one?
by 3.
Yeah, and it's literally just the same thing, exact same thing. I'm just trying to think, is it even worth doing? I don't think it is. I want to see if my calculator has a mode. I think my calculator can solve quadratic equations. Sorry, not quadratic. What is this? Simultaneous. I think it can, but I'd have to figure out. Oh, there we go. So for this one, you have to make them equal to 0. Okay, so for the first one, A is 5, B is 3, and C is minus 118, I believe is how you write it, because you bring it to that side. And then for the second one, A minus 2 and minus 114. Okay, so X, or in this case A is minus 17 and Y is minus 11. B is minus 11. Let me just check something here. Mode, equation. Oh, no, I was supposed to put it. Okay, so it's 17 and 11. Yeah, 17 and 11. Okay. What is the area of the rectangle? How would you get that?
I have no idea.
Well, A is 17 and B is 11.
Yeah. So
what would be the base?
the base would be 11. And oh no, sorry, the base would be 17.
Well, A is 17.
$11 then.
Well, it's A plus 3B. How would you do A plus 3B?
17 and 33.
That's right. And what is that?
40. No, 50, sorry.
Yeah, 50. 3A minus 4B. What would I put into my calculator for that?
3 minus 4b. So 17 times 3.
Yeah.
And then add 44 or minus 44.
Okay. 7. And then how would I find the area?
You do width times height. So it's 17 times 11.
No. What is the base of the rectangle? What is the height?
Base of the rectangle is 3a minus 4b. So 7.
Yeah.
7 times 50.
That's it. Okay. And that's how you get the area of that, 350. All right. Any questions there?
No, nothing. I'm fine, thanks.
Okay. So I'll leave that one. It's a strange question. It's just not very similar to any exam question. Okay. Let's try this one.
So 4x. So you've got to times the top by 3, the bottom by 4.
Okay.
So then you get 12x add 21y equals 3.
Mm-hmm.
So then for the second one times 4, so it's 12x add 40y equals 60.
Okay.
So 12x is the same, but the difference between 19y is 57. So 19y equals 57.
Right. And what would I put into my calculator to get what y is?
Would it be 57 divided by 19?
Yeah, divided by 19. And you get 3. And just be careful with this one. So this was technically 2 minuses, so it made no difference. But yeah. Okay, y equals 3. What's next?
Right, so now we know y equals 3. We can do the rest. So then you can, so it would be 7y times 3 is 21y. Add 4x equals 1. So 4x add 21 equals 1.
Mm-hmm.
So 4x must be minus 0.25. Or is it just 0.25?
Well, 4x is minus
Oh
20.
no, it's minus 5.
Yeah. Minus 5. That's it. X equals minus 5. Y equals 3. Any questions there?
No.
Okay, so 4-mark question, good one. And these are all very similar. What I noticed by going through all of the past exam questions, there's only 2 types. One type is you multiply by 3, you multiply by 2, which we did. The other type is you multiply by 3, multiply by 4. And you can multiply by other things. Like in this one, for example, you can multiply by 5 and 2, but multiplying by 4 and 3 will work. So long as you can do those 2, turns out that you're fine for everything.
Yeah.
And the only exception, although it does use that same thing, is for some of them you have to construct it first, and you can see how this one is 4 and 3 as well, so it'll be the same method. Okay, let's just construct this simultaneous equation. What is
So you got to do 4s add 5l equals 1115.
Mm-hmm.
So then it's 3s add 2l equals 530.
Yeah, and I think we'll just leave it there, because then it's just exactly the same as all the others. The only difficult bit about that was the constructing. Okay, I can solve simultaneous equations by multiplying or dividing both equations, x a half or tick.
I'd say tick.
Yeah. Okay, let's try this one.
Right. So simultaneous equations, 2x and y equals 9. Well, you got to substitute y equals 1.
Mm-hmm.
Right. I do not know how to substitute numbers in.
Well, basically y is 1.
Alright, so y is just 1. So it'll be 9 minus y equals 2x, so x will be 4.
Yeah. Yeah, that's it basically. X is 4, and they already told you that y is 1. Okay,
Yeah.
how would you do this one?
15 minus... Alright, so x equals 2y.
Mm-hmm.
You just leave that. And you could do 15 minus 3y equals x.
Okay.
Oh, wait, no. Oh, no, sorry. Y is 5. Right. Could be 5.
Do it one step at a time. So what would you write instead of x?
1.
No. What does the question tell you x is?
Oh, 2.
Yeah, and so I'll sub 1 into 2, like equation 1 into equation 2. And so instead of writing x plus 3y, I'll write 2y plus 3y. because x is 2y. Okay, solve that.
Right. So 2y could be, we'll say, it could be 3. So that's 6.
Just
Y equals 3 and... Oh, wait. It's just 5y equals 15. And so y will equal 3.
And if y equals 3, x equals...
If y equals 3, then x must equal 6.
Well done. So it's literally just substituting what it is in. Okay, how about this one?
So we'll do what we did last time with it. So x equals 3y, and then 2x add y equals 28. I'm not sure how to start.
Well, 2x is short for 2 times x.
Yeah, so 2 times x add y equals 28.
And instead of writing 2 times x, what could I write?
2x. 2 add x. X.
Equation 1 tells us that x equals 3y.
Oh, 2 times 3.
Yeah, 2 times 3y instead of 2 times x.
Yeah.
Okay, solve that.
So, is y equal 22?
Well, what is 2 times 3y?
2 times 3y is 6y.
Yeah.
So then you're left with 22.
This is 6y, not 6.
Oh, no. Oh, crap. So since you know y equals 3, that's 9y equals 28.
6y plus y?
6y plus y is 7y.
Yeah.
7y equals 28.
Yeah.
So y equals 4.
Okay, and if y is 4, what is x?
12.
That's it. Yeah, so sometimes it takes some manipulating it, but it's basically 2 times x. X is 3y, so it's 2 times 3y. And you go from having 2 equations with 2 unknowns to 1 equation with 1 unknown, and you can then just solve it. Okay, how can we do this one?
So we know that y equals 3, yeah?
This is a new question.
So x equals 2y minus 1. Wait, would you have to do the multiplying thing again? No.
Okay, how would you do that?
So you could do the first one. So you do the first one times 3 and the second one times 2.
I would solve this one using substitution because x and y aren't on the same side of the equal sign.
Oh, so x equals 2. Wait, so how do we know what x will equal?
Well, equation 1 tells us that x is 2y minus 1. So how could I substitute that into equation 2?
I really don't know. Wait. So 2y minus... No, I don't know this.
So x is 2y minus 1. What could you write instead of 2x?
2y.
No?
No, 2y minus 1.
That's right, 2 times 2y minus 1. So it's literally, instead of writing x, you're writing 2y minus 1 because x equals 2y minus 1.
Yeah.
Okay, are you able to solve that?
So you need to do the multiplication first. So 4y minus 2,
Mm-hmm.
add 3y. So it's 7y minus 2
Mm-hmm.
equals 12.
Yeah.
So y could be 2. My y is 2.
Yeah.
14 to equal 2 is 12. And then x will equal 3.
Well done. Any questions there?
No.
And maybe I'll just give you a different way to think about this. X equals 2y minus 1. What does 2x equal?
2x equals 4y minus 2.
4y minus 2. And so instead of writing 2x, you could write 4y minus 2. And that's what we did here, 4y minus 2. So whichever way you do it, you'll get the same answer. I would just literally replace any, like if x is equal to 2y minus 1, I'd replace any x with 2y minus 1 and just go from there. Okay, any idea how we... yeah, any idea how we do this one?
Alright, so Jim is 10 years older.
Mm-hmm.
So you could do, for example, J equals 20.
It would have to be, like, you don't know that he is 20.
So just do J plus 10 or something.
So J plus 10 equals E, is it?
Yeah, J plus 10 equals E.
Hold on. So if he was, let's say, 15 and he's 10 years older than Elise, then that means Elise is 5. The problem is if you put in 15 plus 10, you'd get 25.
Yeah,
So
it'd be minus 10 equals E.
yeah, so it's kind of working backwards, minus 10. Or you could say Elise plus 10 gives you his age. Okay, so that's the first one. How about the second one?
So write out a pair of simultaneous equations to work out Jim's age. The sum of age is 58. So you could do, one of them could literally just be, you need to do 38 divided by 2. Sorry, 58 divided by 2.
That would only work if they were the same age. And we know they're not the same age. How could you write it in terms of J and E?
Because you literally just did it by trial and error.
No. What does it mean, the sum of their ages?
So what both of their ages put together is.
Yeah, so that would be J plus E.
Equals 58.
Yeah, that's the second equation. Okay, how could you solve this?
58 equals E minus J.
Well, 58 equals E plus J.
Oh, yeah. Yeah, so could you just do 58 take away 10, or would there be something to do with that? Or divided by 10?
Well, we can see in equation 1, E equals J minus 10. How could we use that?
Let's do E equals, or J equals, E equals, well,
Yeah.
I don't know what I'll go at the start.
So it's similar to the ones we were doing. Basically, x equals 2y, and so instead of writing x, you can write 2y in the other equation. For this one, E equals J minus 10. How could you use that?
Would you have to use 10?
Well, what could you write instead of e in the second equation?
J plus 10 equals 58. No.
So equation 1 tells us that e equals j minus 10. So what could you write instead of e in equation 2?
Minus 10.
Not just minus 10. What is e equal to?
E equals J minus 10.
Yeah, so in the second equation, you have j plus e equals 58, and instead of e, you can write j minus 10.
Yeah.
Because e equals j minus 10. Okay, can you solve that?
So J add J minus 10.
Mm-hmm.
So you could literally just 68.
Mm-hmm.
Yeah. So J plus J equals 68. Oh no, it's 58, isn't it? 'Cause you need to take away 10.
It's already minus 10, so you have to add it to get it to the other side.
I don't know.
J plus j equals 68?
Yeah, just you have a 68.
Yeah.
So J 34.
Yeah. So j equals 34. And so what is e?
24.
24. That's it. So their ages add up to 58, and Jim is 10 years older than Elise. That's it. Any questions there?
No.
Okay. And so this is simultaneous equations by substitution, and it's literally, if e is j minus 10, then in the second equation, instead of writing e, you can write j minus 10. And so you can eliminate it that way. You don't have to get anything the same. You don't have to add or subtract, anything like that. Okay, I can solve simultaneous equations by substitution. X, a half, or tick.
Probably between half and tick.
Okay, so let's take some practice. Okay, quadratic. Same idea as before, substitute.
So x squared and y squared equals 10, and y equals minus 3. You got to do minus 3 squared, which is minus 9.
What does squared mean?
So it's minus 3 times minus 3.
And what is minus 3 times minus 3?
9. Is it 9 or minus 9?
You tell me.
9.
Yeah, because a minus times a minus makes a plus. So whenever you have something squared, you'll never get a negative answer. Okay, so y squared is 9. So what do I write?
So that means that x squared must be 1, because 1 times 1 is 1.
Yeah, so x squared plus 9 equals 10. X squared is 1. And so what is x?
X is 1.
X is 1. And is there any other number? Any other similar number that x could be?
Could be.
Keeping in mind this thing that we did over here with the plus 9.
Or minus 1.
That's right. It could also be minus 1. So strangely enough, we have two answers. One answer is, and y is the same for both of them. Y is minus 3. So y equals minus 3. Y equals minus 3. And so if I was to draw these two, I think the first one is a circle. Y equals minus 3 is a horizontal line. And so that's why you've got two answers. They cross over twice. The one on the right is 1 minus 3. The x is 1, the y is minus 3. And the one on the left, the x is minus 1 and the y is minus 3. Okay, any questions there?
No.
Okay. Exam question. How do we do this?
So y equals 6. We know that.
Mm-hmm.
So it needs to do 6 times 6, which is 36.
Mm-hmm.
Then it's just 36 add x squared equals 25.
Mm-hmm.
So to get to 36 to 25, we need to take away 11.
Well, what would x squared be equal to?
This could be equal to 11. No, 1.
How do you get rid of the plus 36?
By taking away 36.
Okay, so if you take away 36, what do you get?
Minus 11.
Yeah.
X equals minus 11.
That's right. Okay, x squared equals minus 11. You were asked to show that Bill is incorrect by saying that it's got two answers like our last one. Why is he incorrect?
Because x squared, can't you not do x squared equals minus 11?
Well, what number times itself will give you minus 11?
Minus 5.5.
You're thinking of times 2. This squared is times itself. Why did we get plus 9 for the minus 3 squared?
Because minus 3 times minus 3 equals plus 9. Oh, is it positive then?
Well, if you think about it, if x is a positive number, a positive times a positive will give you a positive answer. Or a negative times itself will give you a positive answer as well, like with the plus 9. So why can't we get an answer for minus 11?
Because it's got to be positive.
Yeah. Because, no answer. Square numbers must be positive or could be 0. But this is negative 11. Must be positive or 0. Or 0. So that's quite a strange one. Okay, any questions there?
No.
Okay. Maybe I'll just write in as well, can't be negative. Yeah, a square number can't be negative. Okay, so this is a more straightforward, well, more work, but a bit more straightforward. So this will have an answer. Okay, how do we do this?
Let's do it just by process of elimination as well.
Never. So if you look at equation 2, y is x minus 7. How can you use that?
Oh, crap. So x squared is x squared minus 7 squared.
Well, you see in the first one, it's y squared.
Yeah.
And in the second one, it says y equals x minus 7. So instead of writing y squared, I can write x minus 7 squared because y is x minus 7.
Yeah, equals 25.
Okay, how do we do this?
So it's going to be x cubed minus 7 squared.
The way I recommend you expand square brackets is you just write the bracket twice and expand it as normal. So what would you get if you expanded those brackets?
X squared add 7. Wait, so you're just doing x times 14?
Well, what is x times minus 7?
Minus x minus 7.
X times minus 7?
X times minus 7.
What is that? X times minus 7. How would you write it?
Minus 7x.
Yeah. Okay, go on.
So equals 25.
So you have to do 2 more things with the... do you use FOIL when you expand brackets?
I don't know how to use FOIL.
So it's basically multiply the first two, multiply the outside two, multiply the inside two, and then multiply the last two. So what would you get when you multiply the inside two?
X times 7. X times minus 7.
Mm-hmm.
Minus 7x.
Yeah.
And you need to do the outside too.
Last two. We did the outside two.
Oh, it's x minus 7 again.
The last two?
Oh, minus 7 times minus 7
Mm-hmm. And what is that?
is 14.
That would be times 2. This is
Oh.
times. And what is a minus times a minus?
Positive.
And so what is minus 7 times minus 7?
Oh, 49, sorry.
That's it, plus 49. Okay, how can we simplify this or solve this?
Right. So there's x squared is x to the power 4.
That would be times.
Is this x squared then?
Well, x squared, it's like 1x squared plus 1x squared.
2x squared.
Yeah.
Minus 14x.
Yeah.
Add 49 equals 25.
And so what kind of equation do we have here if you've got x squared?
I'm not sure what it's called.
Quadratic. Any idea how you solve a quadratic?
No.
You must first make it equal to 0. And so you can see on my calculator, ax squared plus bx plus c equals 0. So we solve these by making it equal to 0. What would you get if you made this equal to 0? How would you do that?
I'm not sure how to make it equal to 0.
Well, instead of it being equal to 25, if you wanted it equal 0.
All of it equals 0. So 2x squared minus 14x add 49 equals 0.
Well, you have to get rid of the 25.
Oh, so you just minus 25 from the whole equation.
Yeah.
So just add 26 equals 0.
That's it. Any idea how you solve this equation, this quadratic?
So would you have to first of all get rid of the 26? Or get rid of the 14, sorry.
You might be onto something. There's something easy you can do would be to half everything.
Half everything. So 1x squared minus 7x add 13 equals 0.
That's it. Any idea how you'd solve that?
You could literally just work backwards.
X squared minus 7x plus 13 equals 0. So the simplest way to solve a quadratic is by factorizing it into two brackets.
Yeah.
Do you remember how you'd factorize this?
No.
Well, what times what will give x squared?
X times x.
So those will go there. And then for the other two, we need two numbers when you're doing the FOIL, the last two. They multiply to give 13 and they add to give minus 7. And is that right? They multiply to give 13. That can't be right. Let me check. 49, 25. What is 49 minus 25?
26.
Let me just press this thing. Yeah, 24.
Oh, yeah, 24, sorry.
And so what do you get when you half that one?
When you have 24, you get 12.
That's it. Okay, and so we need two numbers that when you multiply them, you get 12, and when you add them, you get minus 7.
Alright, so Uh,
And I'd start by listing the numbers that multiply to give 12.
4 and 3.
Okay. Is there any way to make minus 7 with those two?
Yeah.
How?
Well, 4 and 3 equals 7. So isn't there a way you can swap that around to make it be minus?
Yeah, if they were both minus. Minus 4, minus 3 gives you minus 7.
Yeah.
And so what goes in the brackets?
Minus 4 and then minus 3.
Well done. Okay. Any idea how we solve this now?
X minus 4 times x minus 3 equals 0.
Right.
So x minus 4. You have to do multiplication. So it's x times minus 4.
Well, if you've got two things that multiply to give 0, what do you know about two numbers that multiply to give 0?
So the whole equation is just x equals 0.
If two numbers multiply to give 0, what do you know about at least one of the numbers?
It's going to be 0.
Yeah. So either x minus 4 must be 0 or x minus 3 must be 0. So if x minus 4 equals 0, what must x be?
4.
Yeah. And the other one?
3.
Well done. So that was for this one. X equals 4 or x equals 3. Is that full marks?
It is, isn't it?
If they want the solutions for simultaneous equations, you must also find y.
So now we know x equals 3 or 4.
Yeah. So x equals 3 or 4, y equals x minus 7. So what would be y when x is 4?
16x minus 28.
Y is x minus 7. X is 4.
Oh, 4 minus 28.
You're not multiplying anything. It's literally just y is x, take away 7.
X.
So when x is 4, you get y equals 4 minus 7.
Yeah.
And what is
Sorry. Yeah, I should have just done that.
and what is 4 minus 7?
Minus 3.
That's it. Okay, when x equals 3, what is y?
When x equals 3, and y is minus 2.
3 minus 7?
3 minus 7 is minus 4.
That's it. And if you were to write the answers as coordinates, so you had two things. One was a circle, this top one. The other one was a straight line. And so that gives two solutions. How would you write our answers as coordinates of where those solutions are?
I don't know, you'd write it as like coordinates.
So like for coordinates, what would be the x, what would be the y of the first coordinate?
Oh, 4 and then minus 3.
Yeah.
Because it's across the corridor up the stairs. And then 3 minus 4.
Well done. And so, yeah, I'm just kind of trying to make sense of the answer. It's not just a weird random thing. That's if they asked you as like what are the coordinates of where they cross over, the coordinates would be 4 minus 3 and 3 minus 4. Basically, the y equals minus 3 answer matches with the x equals 4 answer, and the y equals minus 4 answer matches with the x equals 3 answer.
Yeah.
Any questions there?
No.
Okay. And you can see here, same idea. X equals 2y plus 6. So instead of x, you write 2y plus 6 squared, and then everything else. You expand the brackets, you get two answers for y, and use those to get two answers for x. This one, exact same idea. Y is 2x plus 5. So instead of writing y squared, you write 2x plus 5 squared. You expand it out, factorize, get the two answers, and use goes to get the two y's. This one exactly the same. Yeah, I can solve quadratic simultaneous equations by direct substitution, x a half or tick.
I'd probably say, I don't know, it's either between tick or half tick.
And there's one last thing I'll just show you. For this one, they don't have it. So the reason why we were able to substitute the previous ones is because they were always either y equals or x equals. So instead of writing x, we could just sub in what it's equal to. This one isn't y equals or x equals. How could you make this one y equals or x equals?
We just get rid of the 2.
Well, let's just pick one. Let's just say x equals. What is x equal to?
2.
Well, x plus y equals 2. So x equals?
1.
Mm,
Or should we say just quite a number?
how do you get rid of the y from the left side?
Just can't you just take it away?
Yeah. So if you take it away from both sides to keep them equal. So what's now on the right side?
X equals 2.
Say it again, sorry.
X equals 2.
2 minus y.
2 minus y.
Yeah, because you had to take away the y. Let's say you wanted, so you had x plus y equals 2. Let's say you wanted y equals. How would you get y equals? At the moment you have x plus y.
Y equals 2 add x.
Well, it's add x on the left side.
Minus x.
Correct. Yeah. And so you could write it as x equals 2 minus y or y equals 2 minus x. Same thing. And then you would then sub that in like they have. So x squared plus, instead of y, you write 2 minus x squared because y equals 2 minus x. And you would solve it exactly the same way. You can see this one, y equals x plus 3. For this one, what would y be equal to? It won't be a number, just in terms of x. At the moment it's y minus x. How would you make it y equals?
Y equals x plus 3.
Correct. And then you would solve it exactly the same way as the other ones. Instead of y squared, you would write x plus 3 squared because that's what y is equal to. And you would solve it by substitution. Yeah, I can solve quadratic simultaneous equations by rearranging and then substituting x a half or tick.
Oh, probably a tick.
Okay, so that one is very similar, but I just gave you an idea of what it looks like quickly. Yeah, how did you find that, James?
Yeah, it was good.
Any preference on what we do in our next lesson?
Whatever you think.
Okay, I'll pick something.
Alright.
Any questions for me in general?
No.
Okay, well done, James. You did great, and
Thank you.
look forward to talking to you next time.
Yeah, alright.
All right,
Thank
have a
you.
good one.
Bye.